Welcome into the ProtoPod, the show where we talk to innovators, engineers, and entrepreneurs who are shaping the future of technology and manufacturing. Today's guest is Tom Mikolyuk, mechanical engineer and early team member of Chiplytics, a Seattle-based startup that's making the world's electronics safer by testing chips using a groundbreaking technology called power spectrum analysis. Tom joined Chiplytics as their very first intern and went on to become their first full-time hire. Since then, he's helped lead hardware development, product design, and system integration as the company's grown from concept to funded startup. We'll talk about how Chiplytics is transforming electronics testing, what it's like working at the intersection of hardware and software, and the lessons Tom's learned helping build a company from the ground up. Welcome in, Tom. Tom, welcome on to the ProtoPod, the lead product engineer at Chiplytics. I'm excited to learn more about what you and your team do.
Thank you for having me on, Jordan. Excited to chat.
I guess, do you want to just take me through your journey to joining Chiplytics? I know you were an intern there, but walk us through your journey into being lead product engineer.
Oh, man. I mean, it's very, well, because I've only been in full-time engineering for 2 years, not counting stuff I did in college. It's quite linear, but also quite lucky. I was, like we talked about a little bit, the very first intern at Chiplytics. And it was basically one of the co-founders established a hardware lab in Seattle for prototyping near the company's founding in 2022. He had wanted a mechanical engineering intern from a local university, well, preferably so that they could start as soon as possible. I went to the University of Washington. I was a senior at the time. And so I was literally sitting doing research in a composites lab in the basement of the mechanical engineering building at the University of Washington. If you ever get the chance to go there, it looks like a high school. It's one of the ugliest buildings on the entire campus, but it holds a very big space in my heart. When I got that email asking, hey, we need an intern quickly, I sent them a cover letter, a resume, I interviewed with them. They liked me, they hired me, they rehired me for another quarter. Then once they got enough funding, and I was kind of recruiting for other jobs senior year, but I knew in the back of my head that they wanted me back. They hired me as the first full-time hire, product development engineer, and then I did good work and got my title changed and a responsibility bump. So now, instead of just being an intern and focusing on one project, to being an intern again and focusing on a whole product, to being a full-time entry-level engineer and focusing on the entire product line. Now I'm recruiting, managing interns. I'm leading a lot of the system integration and mechanical design work. I'm functionally the mechanical engineer for the company. So it's sort of been part of the journey is luck, obviously, right? But also a lot of preparation, where a lot of the work in sort of interdisciplinary product design that I did in college, and sort of taking every opportunity at Chiplytics and saying yes, just want to get involved this and that and that and that. I want to take more responsibility here and here and here. Sure, I'm down to be the guinea pig for this. That's kind of, it's what success meets luck, or success is luck plus preparation or something. So that's the short of the journey, but I'm happy to dive in it.
Yeah, I think that's a really interesting story. And I mean, it's, pretty amazing how much you've accomplished and how much you've been willing to take on. And I believe one that I've heard is luck is capitalizing on opportunity or something to that effect. And I think you've done that really, really well, which is hats off to you. Tell me, I guess, a little bit about what sets Chiplytics apart and what drew you in to take on responsibility and grow yourself at the company.
Absolutely. Well, in sort of early 2020s entry-level engineering job market, on one hand, you kind of take what you can get, right? Yeah. And I had come in. This was my first and only internship in college, and so I was like, okay, I'm gonna take this. But I didn't continue to choose to be at the company just because of that, right? Which is what you're alluding to. I think from like even in high school when I had opportunities to take product design and engineering and industrial design classes as part of my curriculum, I was really interested in sort of, okay, like when I think about the kind of work I want to do in the future, I want to have a small tight-knit team and I want to be working on translational things. Like there's some new technology. How do I use my skills and how do I work with others to actually make it into a real thing that improves people's lives in some measurable way? I think what really I had a good internship, and a lot of that was because tiny team, but repeat product developers from different industries, repeat founders, all that. It showed like they really put a lot of effort into not only like how am I able to serve the company as an intern, but also how am I growing as an engineer? How am I bringing together different disciplines and really like developing products that actually work and that meet people's needs, which is something that is kind of brushed on in undergraduate mechanical engineering curriculums in North America, but is not always like practiced.
I would agree with that.
Yeah. Well, exactly. It's in your background, right? And so it's like a lot of it is like it's the kind of the environment that I wanted to be in, and it also really helped that the people were supportive of me starting my career in that kind of environment. And it has paid dividends in the sense that like I could have just continued to be a good mechanical engineer and it would have been okay for the company. But as a result of me continuing to ask for opportunities, they are happy to just continue giving them to me. And that's sort of, I know that there are a lot of places in sort of the larger corporate world where there isn't as direct of a conversion between effort and result. And it has been really gratifying to be at a place where the more I put in, the more I get out of it, outside of like getting a paycheck and paying rent and like stuff like that. It's been really much a place to like grow as a person.
Yeah, I think.
Yeah.
No, I think it's incredibly well said, and I want to dive into that a little deeper. I do think it's that tie to result, and this is something that we have touched on the show, and I see it both working with customers or internally with our team, in that people really are the most satisfied when they can tie the work that they do to a result. Right?
Yes.
It's not just a checkbox. It's something that becomes actualized and has an impact, whether that be on your company or your customer. And I do think that's the highest level of engineering work, is when you can see that. It's really special. Before I get into that a little bit more, I did want to ask you, from a technology perspective, what is it Chiplytics is doing differently in the sector, and how are you and your team, I guess, solving problems uniquely for the industry?
100%. It's a good question too, because this has been a lot of where my personal growth has been over the last years, figuring out how exactly do the co-founders communicate this. Like I didn't know much about semiconductors going into my internship or even my full-time role, right? And what I found out through being in the room with a lot of customer discovery sessions and going to initial pilot clients and stuff like that, is that the industry of electronics testing is kind of the traditional industry that's ripe for disruption. And what I mean by that is sort of the framework in the 2010s of like social, like Uber is disrupting rideshare and social media, or Facebook is disrupting social media, that kind of thing. They approach a traditional industry with a different business model and different product that is more suited to people's needs and increased throughput and automation and stuff like that. The current testing techniques that are standardized are quite manual. And there is a lot of different techniques that need to be used to certify parts for different industries, and they all take a lot of time and a lot of labor. And so that reduces the throughput. It increases the capital costs that companies need to spend to get different kinds of equipment to deal with different types of chips. You have like ones that have little leads on them and they kind of look like bug legs. You have ones that are way bigger and have a bunch of different solder balls on the bottom. You need entirely different equipment sometimes to test those two things. And so there's two kind of areas where Chiplytics has been doing things differently. For one, it's the technology. So power spectrum analysis is something that it kind of has existed for a decade, but it hasn't been commercialized. It is non-destructive electrical testing. So when people test chips to AES or ISO standards, they oftentimes have to destroy some chips by removing their packaging to look at the inside of the silicon to see if it matches what the spec sheet says. And as a result, you lose a chip that the customer could have used in a product, right? Instead of doing something physical, this technique basically, I can go into it more later, but it looks into the electronics of the integrated circuit itself and can do that same comparison without having to destroy any useful units. And so that technology is something that's different. And because it uses less leads, you only need a power and ground connection. That also leads to the second thing that Chiplytics do differently, which is the automation aspect of it. Removing a lot of the manual labor, removing a lot of the different capital costs, and allowing higher throughput and more efficiency for our customers to serve their customers. And so this is where we have the micro inspection platform that is essentially like has all the power spectrum analysis technology, but is automated onto probes. If you've heard of like flying probe machines, for example, that assemble PCBs or probe PCBs, it's kind of like that, but simplified. And so what we've been seeing is like, not only is the technology a big draw, and the automation is a big draw. And so this is where we have like our team is experienced in automation and mechanical engineering of that kind, and also experienced in electrical testing, research, that kind of engineering. And so we're doing a lot of things as a very small team, but that is like sort of a dual-pronged approach to our unique value proposition, essentially.
Yeah, it's a great description. It paints a very good picture for me, and I'm sure the audience. So it's really all about, at the end of the day, decreasing direct cost through scrap that is required to do this testing, and to do it much more efficiently, both to get more product through and also I guess reduce the cost in doing that, labor cost, what have you. So what is the equipment that you deliver? I know you're the product engineer. What types of products are you guys delivering? They're automated, but what do they do for your customer? What do they look like?
For sure. So I guess what do they look like in a physical sense is just the power spectrum analysis box, which is literally a metal box that we're actually working with Protocase right now to iterate on. That you put a chip into a socket that sticks out of it, and then that chip, like when you connect that device and that chip to your computer. Your computer is running an app that we develop that basically runs the electronics that are inside the box. And so that just does the power spectrum analysis test on your computer. You can take data from a bunch of different samples that you collect using that box and run algorithms on it, like principal component analysis, k-means, whatever, to cluster different chips together so you can see graphically what chips might you have that are outliers to the rest of the set. And if you have a golden sample, which is that this chip is from a manufacturer, you have that data point, you have that like sample you collected in the past, then you're comparing the chips that you have to that golden sample. The automated version, which is the micro inspection platform that I mentioned, uses a lot, like the way that we actually have it be automated is through a lot of robotics and computer vision. So we have a robot arm that collects, that's mounted in a metal enclosure, also designed by Protocase, manufactured by Protocase, that basically collects chips from a tray there's a standard for this called JDEC. So we use a JDEC-sized, like custom trailer manufacturer that has a static dissipative mat on top of it. That robot picks a chip up and moves it to a set of probes that moves in a workspace, roughly 40 by 40 millimeters. And then we have a camera that aligns the robot arm to the chip when it's on the tray. We have a camera that aligns the robot arm that's picked up the chip to the different probes. And so that entire like process of when you're using the automated system, you know what chip you're testing ostensibly, you know what pins are supposed to be the power and ground. You tell that same app that I mentioned previously what pins are supposed to be tested, and then the system does the rest. So in terms of like what that looks, that's like the UX of it. But what I've personally started pivoting to as like an understanding of our products, especially as we shift to more like not just creating products, but also doing the chip testing itself using our methods, is our product really is trust. How do like we trying to think of how to best say this, and I'll get lost in my own words. Essentially, we have the method that tests chips faster and easier. We have the automation that makes that possible to high throughput, and that contributes to our customers and the public at large being able to trust the electronic supply chain, which, especially in the 2020s, as a result of the chip shortage, like that is of paramount importance. And so that's where it's like the product that as lead product engineer I'm offering, right? As I've transitioned to more of a lead role, I've had to think more about what is it that I'm building physically, and then what is it that I'm building like metaphorically? What is our true product?
Yeah.
And that's, as a startup, we're happy with today. But.
It's incredible, and I again, the visual and the description of the product itself was very helpful to me as somebody who never saw one of these before. So, and I you know, the connection to at the end of the day, what you're delivering to the customer is trust or confidence, and you know, faith that they know that this product that they're testing is going to perform as they expected. Obviously, you know, that visual was very enlightening, and also kind of gives me some perspective on maybe some of the technical challenges that may come with offering such a broad spectrum all-in-one solution that includes hardware, software that is automated, and drawing back to what you had talked about a little bit earlier with, you know, the scope of work and integrating disciplines and all of that stuff. It sounds like it's pretty challenging, or it could be pretty challenging. Do you want to walk me through maybe what are some of the largest challenges that you and your team have faced, and how you've overcome them?
Absolutely. So the company exists because we have a license from a national lab to commercialize power spectrum analysis. That national lab did, from what I understand, the bare minimum research to determine that power spectrum analysis can differentiate between two chips from different date codes, which basically, like, if you have a chip manufactured at the same fab, on the same line, same type of chip, but on different days, that can tell, like, this technique can tell those two apart.
Wow.
And so that's kind of it, right? We don't know necessarily the full details of temperature variation, or how important pin contact is, or whether, like, how it detects degradation, or what these sort of, essentially what we get from power spectrum analysis is a signature of, like, a fingerprint of all the internals. And so what do those signatures actually look like for different chips? Are there any identifiable, like, waveforms or frequency bands that certain, like, trace lengths or different transistor arrangements, like, actually reflect? What do we actually do with these signatures? So for that reason, we have research contracts with universities and the US government to push forward our understanding of the technique. But before we had that, in terms of our product development, we were making, boxes and just kind of hoping for the best. And this is where it's like overcoming a challenge of like, hey, we actually don't know how to best design for this method. Is we try, we iterate, we work with people to continue developing this product, and like the product of power spectrum analysis. And over the last 2 years, or even as an intern, where I designed the pilot power spectrum analysis device, our understanding has grown leaps and bounds, which is why we're moving to a all aluminum enclosure, because electromagnetic shielding turns out to be really important. And we knew, like, in our heads that it probably is, but actually like quantifying it tangibly and seeing how important it is a big thing. The other challenges, or big challenge, let's say, that we face as a team is that automation aspect, in the sense that, pick and place robots exist already, right? Like you're loading huge reels of components into this big box that fills up like a quarter or like half a room to like place them on a printed circuit board and like create products. Like this is what contract manufacturers do, right? But the way that we have to deal with many different chip packages and localize onto specific pins with the most cost-efficient equipment possible means that we've had to get really creative with how the different components of our system talk to each other and how we get to different positions. So using like open source models for computer vision and educational like product cobots and off-the-shelf microcontrollers and stuff to really build a minimum viable product that we can show works and provides tangible benefits is a big engineering challenge. And so that in of itself, I can go into more details on like the software and the mechanical and stuff like that, but they're in the development of the micro inspection platform over the last 1.5 years or almost 2 years, that's been like a biggest source of iterations is designing a big light box that goes around, because lighting is super important with computer vision, and we didn't know how important it was until we had built a prototype and tested it out.
No, so. It's perfect. I mean, it's such a common theme on the show, and that idea of really the language that we would use is iterating to find your unknowns, right? Yes. So you've got an unknown in how the technology works. It's very new. There's a lot of unknown unknowns, things that we have no idea about, down to some known unknowns on how we're going to place the different shaped chips in the right spot. And there's all of these things. And really, the only solution is getting to something that's testable as quickly as possible, right? We talk about that moving at velocity on the show, and how if you're able to do that, if you ruthlessly eliminate latencies as much as you possibly can by coming up with an MVP, scoping down, using duct tape solutions, you'll often get to a place where you've resolved those unknowns much faster, and then you're kind of at the top of the hill, as a little analog or euphemism for the path along project development or product development, and you can see a little bit better, and then okay, this worked. I believe I wrote down you had mentioned about in the technology the EMF. That's what it was, and you now know that's a problem. So now you can redirect your next step, and it sounds like such a basic principle, but I do think that it's something that I can't stress enough in how important it is and how impactful it is. And I'm sure you feel much the same way based on the head nods.
Absolutely. Off the screen, I've been violently head nodding. Yeah, it's so much easier said than done, and I didn't know how much easier it was said than done until I went and did it. And I'm sure that's a common thread in a lot of the conversations you've had. Like, you don't know what you don't know a lot of the times. And part of my role is to try to push us to fail forward as much as possible. Also in an industry that is less, I guess, receptive to duct tape solutions too. So this is where, it's been such an interesting challenge understanding the industry that I've got myself into, understanding the product space and also really managing all of these sort of high level product development things. It's been awesome. Wouldn't have it any other way.
Yeah, and eventually, like as you said, right, when you get to a product that has to go to market and things become different, but at that point you should have resolved most of the unknowns anyway, and it's less important to do those things. Is there any? I mean, do you have an example of a specific unknown or a specific situation where you thought that you ruthlessly eliminated latencies and did the best you possibly could in creatively resolving a previously unknown variable?
Oh,
it's a hard one. There's probably lots.
Yeah, absolutely. It's hard to think of one that like I can also concisely explain.
You don't have to.
No, this is all right. I think this is related to like the sort of automation stuff. We have, so I mentioned there's two moving probes that localize two pins. If there's even as much of a 0.3 or 0.4 millimeter difference between the heights of those pins, they're compressible. They're pogo pin. They've converted them before. So there's like a little like shaft that moves in and out like in the spring. Perfect. Okay. If there's even like as like order of a 1/10 of a millimeter of a height difference, the chip will tilt, and then depending on how strong the suction is, may either stay or fall off completely. And we got precision linear stages. We got machined components. And so ostensibly, there should be a very small tolerance range for all of those. But when you stack them up, when you get assembly issues, because we are still, we're prototyping, we're hand assembling units and everything, there are a lot of unexpected issues. Like we had, I think something like a 0.5 or like 0.8 millimeter difference, and that was causing chips to fall. I took apart the entire stack of like 5 or 6 components of one of the like the moving probes, and found that 0.3 millimeters or something of that stack up like difference was caused by a protruding helicoil from the bottom of one of these parts. It's like stuff that's as small as that, where like we thought that as like we have put in all this effort to make the differences between the pogo pin heights very, very small. Turns out it's not enough, and you have to really dig deep to understand what are all the possible factors that could change that. We also saw that one of the linear stages was like the top of the carriage that moves back and forth on the linear rail was tilted. And even still, we haven't like fully understood why, but we put in fixes to do that. And so this is another place where like we thought we mitigated an unknown, but in the future, I will have to possibly resource these parts or put in more quality controls, like more of an IQC, like an inbound, to figure that out. And as we're moving towards creating more of these units, that is something that's going to be one of my biggest projects.
Yeah, so. The manufacturing challenges, and that's very, very insightful, and something that I don't think, especially people coming out of university or college, are really exposed to quite enough, and those things will bite you. I know from personal experience. Again, I've had a few of those, especially in my young career. I'm curious, Tom. I know you've done a lot in your young career, and are very insightful as to the value that you get from your work and what you enjoy about it. I'm curious if you had advice for maybe some students listening as to where they should head in either their education to be more prepared for the real world, but also to finding that thing that they love. What advice would you give them?
Absolutely. I mean, this is a thing to think about a lot too, because of my position managing interns and like mentorship and stuff like that. I didn't do a traditional like engineering student experience where like you do Formula SAE or you do another build club or stuff like that. I knew that I had wanted something to do with consumer electronics or like biomechanics or things that like face people more directly than automotive or space or whatever. And so I chased that. And because I chased roles there where it was more of cross-disciplinary kind of hacky um, product management kind of stuff. Or I know product management isn't necessarily as hacky, but the point is like to be like almost a full stack mechanical engineer, and really see like the product development process from end to end. I ended up getting into a role that's like that, and I think I was able to put a lot more effort into it because I found something that I truly enjoyed, even though it was off the beaten path. What I do regret not doing as much is though like those build clubs, because what I didn't realize was, okay, even though I would be working on cars, which I wasn't as interested in, there's still lots of transferable skills. And like an intern that I've had over the last 2 years who's been really successful and like contributing mechanical engineering work to us, is somebody who is from those build clubs and has even like honestly taught me how to do metal manufacturing better and CNC machining better and GD&T better and stuff like that. And so if I were to give any advice, is that there's only like you're told to like follow your dreams and all that, right? But I think part of what you're given opportunity to do in college is to explore and to fail forward and to draw as many transferable skills as possible from different opportunities. So I would encourage students to evaluate their blind spots, essentially. If they come into engineering school, like at the University of Washington, you don't choose a major until after your first year. And so they really provide have an emphasis on exploring different majors, even though a lot of the students realistically come in already knowing they want to do aerospace or mechanical or electrical. Does the student have a blind spot there? If they want a particular kind of job, like if they want to work at Boeing, why do they want to work at Boeing? What is interesting to them about it? If they want to do manufacturing, how can they explore manufacturing in different areas? So you apply to a club, which there are competitive applications for clubs now, and you don't get in. How can you design a project for yourself or do research or do independent projects with the professor to get those same skills? So I think in essence, it requires a lot of like critical thinking and self-reflection. And really after that, if you are doing something and you know what you're doing it for, and it feels true to you, then you can do no wrong.
Yeah, I think I don't really have anything to add. I couldn't have said it any better. The evaluate your blind spots, I think, is a great way to put it, because then that's a very concise way, to look at what you're being exposed to, and make decisions that work for you. I know myself, again, like looking back, like, yeah, there's certain opportunities like FSAE, that it like for manufacturing understanding and tolerances and that whole process, it's incredible. But maybe somebody's really comfortable with that, and what else can they be exposed to that would help them in their journey? So I think that's great advice. I did want to ask, I know we've talked extensively about Chiplytics and what you guys are doing now. Where do you think you guys will be in 5-10 years? What's on the horizon?
That's a great question. And I think something that possibly the executive top brass can provide, aka the rest of the team, it's not me, but I've been in conversations in this, right? And they have in front of me from like thinking about my own vision too. We want to be in a place where we are securing every part of the supply chain, from my perspective, from open market, gray market, white market, every type of place that chips possibly come from. We want to integrate a bunch of different methods. We want to be the go-to when people think of how do I make sure that what I'm buying from Intel or from elsewhere how do I make sure that it does, like, that thing that I'm buying does what the person says it'll do? I'm losing my words here.
That's good.
But basically, yeah. So when thinking about that, there's so many ways to approach that, where we are no longer just a product development company, like I alluded to previously, where our product is more trust. And there are so many places and so many vectors for that trust that eventually this might expand beyond purely commercializing power spectrum analysis. There are possibilities where we are in authorized distributors, in independent distributors of chips, where we are in fabs checking yield, like doing yield verification on dies. Really, the core of it is like, okay, automated testing. And there's so many places to take that. And I think that, like, within the next 5-10 years, we are positioned with our team, with our products, and with our ethos to be in a place where we are the basis of securing and authenticating the chip supply chain and making our world a safer place to live.
Incredible. I can't wait to watch where you and your team go. I mean, I think the vision is so clear, and I think that's a really good sign. And I think that you guys will broaden the installation of trust in the industry. Super excited to watch it happen. Before we conclude, I wanted to run through our rapid fire question segment.
Fire at me.
First question: coffee or tea?
Coffee. I'm from Seattle.
Yeah,
coffee is in my blood and everything.
Yeah, stupid question.
Not stupid at all. It's okay.
One piece of tech you couldn't live without?
Oh man, another really good question. I think this is kind of a cop-out answer, but my laptop. I have an M4 MacBook Pro, which, for a mechanical engineer, why are you using a Mac, right? I think it really powers my work and just my life in general. I love doing just anything creative outside of work too. I've dabbled in graphic design, ceramics, other 3D modeling, and this isn't. I'm not a shill for Apple, but my Mac really enables a lot of that. So I will live with needing a SolidWorks workstation.
It's a compromise you're willing to live with. Early 100%. Bird or night owl?
Early bird.
Early bird.
There's nothing better than a peaceful sunrise when nobody else is awake.
Absolutely. Favorite place to go for inspiration?
Any makerspace. Anywhere. Yeah. Anywhere I'm surrounded by tools and other creative people.
One word to describe yourself.
I'll use two. Unapologetically curious. I'm a yapper and I love asking questions.
Very fitting, I think. Book or podcast?
Podcast.
Seinfeld or Friends?
Oh man, Seinfeld. One of my favorite bits is to use my friends, or even at the office sometimes, is what's the deal with? I will never live that down.
Yeah. What's the deal with? Dream collaboration.
Oh, I grew up watching Casey Neistat. So for personal reasons, like, his method of creation is so interesting to me. I grew up wanting to live in New York because of him.
And ride a skateboard.
And ride a skateboard and all kind of stuff. But part of the reasons why I got into so many creative hobbies is because his DIY ethos is so compelling to me.
Yeah, he's mind-bendingly creative. It's
Absolutely.
It's crazy. Sci-fi or reality?
Sci-fi, because of the storytelling again. Yeah.
Last one, most useful skill for an engineer?
Communication, hands down. You can design anything in the world, but communication gets you understanding what you're designing. Communication gets you understanding why you're designing it. Communication lets you communicate to the user what you're designing is important. engineering begins and ends with communication. Our world begins and ends with communication. I have my job because I could communicate well. I'm not the best engineer in the world. I wasn't the best student in the world, but I could break down technical concepts, and explain them to people in a way that is understandable.
Yeah, I was going to say, I think you've mastered that one, Tom.
Like, well, don't stroke my ego too much.
I think you have, for sure.
I appreciate that.
If people listening are looking to learn more about Chiplytics, where do they find out more about you guys?
We've got a website, Chiplytics.com. It shows a lot of our products, sort of a more technical and more detailed explanation of what we do. I would also encourage people to, reach out on LinkedIn. Obviously, like my first and last name, I'm assuming you're on this episode, and I'm happy to answer any questions on LinkedIn. I just try to be a resource for people with product development all the time. I'm not going to put the. I'm not going to say it's the same for my coworkers because we're all busy, but I would be very happy to connect people with them, and they generally also love talking about their work and stuff like that. But reach out to me first, or chiplytics.com.
You're the buffer. Well, Tom, thank you so much. This has been awesome, super insightful about a world that I knew nothing about, and I really, I think, to steal your term, you're kind of, you're breaking in and you're totally disrupting a legacy industry, and I'm excited to see where you guys go.
Thank you very much for the invite, Jordan. It's great talking to you too.
Anytime you want to come back on, feel free. We'd love to have you.
And if you're in Seattle, don't be a stranger.
Absolutely. Okay. Until next time, Tom. Bye-bye.
See ya.